Hey, everybody. Welcome to the Avalanche Developer Community Call. I am Gabriel Cardona, a developer evangelist from Ava Labs, and I'm very excited today to be joined by three amazing engineers from our team. We have Patrick O'Grady, Stephen Butoff, and Aaron Buchwald. Thank you so much, gentlemen, for joining me. We're all very grateful. As always, the community is always excited to get insight from you guys, and so we're very grateful for your time. So I'm going to be handing off the mic now to Patrick. We're going to start off by talking about a summit recap, maybe some of the exciting announcements and best memories from this year's summit. So take it away, Patrick.
Cool. Yeah, so Summit was now about 2 weeks ago in Barcelona. It was great to meet everybody that made it there, and bummed we didn't catch you. If you couldn't make it this year, we'll see you next year. At Summit, we talked about a lot of updates to what we're working on and what we're doing. I think all of us gave talks at some point. And so I think what would be good is to maybe go around real quick and maybe explain a little bit about what you talked about, and then also cover maybe your favorite part or what you enjoyed most about Summit this year, at least from the dev side of things. So we'll start off with Stephen, if you want to lead us off, then I'll wrap it up at the end.
Yeah, sure. So again, thanks for having me, guys. I gave a talk at Summit on the Avalanche linearization, so the Cortina upgrade. And so I went kind of deep into all things Avalanche consensus, which I've always avoided giving a short form presentation on Avalanche consensus because I always kind of struggled to condense it into an understandable format. So I did my best. I don't know necessarily if I succeeded, but I think that's what these calls are for, is to answer any questions post when that video gets uploaded. So I believe all the talks are going to be uploaded to YouTube at some point. So that'll be a really good resource, I think, for people looking back. And I definitely look forward to answering more questions on any of that in the future. I went over all things kind of like DAG, subsampling, and then the actual like conflict set management and how we use DAGs to actually represent the conflict sets for non-transitive conflicts. So anyways, I think it's very interesting, maybe a little dense, but yeah, I had fun with it for sure. And then I think my favorite part of, or my favorite kind of like thing that happened at Summit was at one point I managed to surround myself with a bunch of security researchers in the overarching kind of blockchain environment. And so I was able to have kind of a really like long and in-depth talk with all of them, talking about kind of like what threats they kind of look for, what threats they see, kind of their opinion on projects, their opinion on auditors, things like that. So really just kind of like connecting with the broader kind of like security community is something I always love to do, because definitely as a protocol like engineer in a BFT environment, security is always your kind of like number one thing on your mind. And so that was definitely something that stuck out that I really enjoyed and definitely like to do again. So yeah, I think that was probably my one bright spot that I'll throw out here, and then I'll maybe throw it over to Aaron to give his thoughts.
Yeah, I'll start out actually with my favorite from Summit. Overall, it was just a really great experience. Last year, I think my takeaway was it was the first time meeting the community in person, and I came away from it just amazingly motivated because of just how awesome it was to meet all of these people that were excited about what we're building for the first time, and to see that passion in other people. I came away from it was just insanely excited. I think I might have told Social, I was like, yeah, like, I just want to like not leave the office for like 3 months. And she was like, are you serious? I was like, yeah, like, I'm not. Social I've canceled. Which, and that was really exciting just to meet everybody that cared so much. And I think the takeaway this time was beyond just meeting people that were passionate about it, actually being really impressed with all of the projects they're building on Avalanche and really excited about what they're building. At times even more so than what we're building. It's great to meet people from the Cavalry team. They're doing some really interesting stuff there. Got to chat again with the Trader Joe teams. Obviously, we're at the last Summit too. but also talking to them about a lot of the innovations that they've been building with the liquidity book is super interesting, and all of the other subnets that are building on Avalanche now, as well as security researchers that are getting more involved in the space, people building different key management solutions, all sorts of things, trying to build a better development environment for everything Web3 was just really, really just awesome to see the quality of people building the Avalanche ecosystem now. Oh, and then also, I almost forgot. So I gave my talk at the Avalanche Summit about integrating Avalanche warp messaging into the EVM. So that should be up on YouTube relatively soon. Like Steven, I have no idea when, but I was really happy with how the talk went. Always happy to chat with people about warp messaging, especially in the EVM. And it was great to give that talk and see the crowd that was there. I think last year when I gave a talk, it was on Saturday during the hackathon, and there were like 5 people there. This time it was completely full. So it was really cool to see the evolution of builders, and there were a ton of great questions about exactly how it works. My goal was really just to get to the point that everyone sort of understood how warp messaging worked from top to bottom. People told me that they got it, and so I think that was a really big success, and I'm really excited to see the YouTube video when it comes out, continue to answer any questions. And until the YouTube video comes out, if anybody's interested to learn more about it, the PR is up on Subnet EVM is public. It's still under development. It's sort of in a testing cleanup phase right now, so we're continuing to go through more audits. But there is a README there that's fully public and walks you through the entire thing from start to finish. So if anyone's interested, I highly recommend checking that out, and would love to get more thoughts from the community on how it's implemented and get more eyes on it as well. I guess I'll toss it over to Patrick now.
Yeah, I think I'm going to give a quick recap of a few of the technical things that we brought up. I have some slides up here, so I'm going to share those as well. So let me share my screen real quick. Cool. Kyle, if you could. Yeah. So the first thing I wanted to recap a bit was some of the stuff that Goon announced and was really excited about. And that is this notion of coin-operated agents. And so this slide deck is actually available on Twitter, as well as his full talk on this. So if you haven't seen that yet, please check it out. I think the team here can link the Twitter post in the comments here. But wanted to give a quick overview here, as Goon and I talked about this a bit when he was thinking about the idea. And so, long story short, there's a few challenges. I guess like many people have been blown away by LLMs in the last 6 months, myself included, in terms of like what their raw capability has seemingly happened overnight. Obviously, no change happens immediately overnight, and this has been the culmination of years of research. It just so happens that it's working really, really well now, and that it doesn't seem to be a limit, at least practically speaking, for like how many parameters these LLMs can support. So far, you just train it longer and make a bigger LLM, it just gets better. Obviously, I'm definitely trivializing a very complex topic, but nonetheless, for the average person, it has enabled them to somehow acquire superpowers, right? If you want to have write a 5-paragraph essay on something very specific that matters to you with some source documentation, that now takes 10 seconds, where it used to take you 6 hours maybe to write something of that quality. And so people have thought, well, what else could you apply this technology to, right? So some people have started to use it in search, like Bing. And Goon was really interested in the idea of potentially using it directly as a virtual machine. And what that means really is that when you, write a contract, the idea here is that when you write a contract, instead of actually like writing code that specifies its behavior, you instead define its behavior using a LLM or like an LLM prompt that people can add to. Now, this is not to say that you could work, it would work well like right now today, as much as like outlining the vision for how this will work over the next few years. And so, you could imagine, right? Like I myself included love these, like trying these prompt injection things to the LLMs and seeing what you can get it to do. And so you can imagine in a blockchain context without proper error bounds that like you could say, hey, like, write this contract that is a token that like manages balances between users and now transfer 5 to Bill. And then, add some prompt injection attack that allows you to take all the tokens and get them to Bill, or like mint infinite tokens. And I was joking around with Steven at Summit. It's like you almost want to ask the LLM after it does anything, are you sure? To see if it will, continue to do that step if needed. And I think early on, as we start to play around with this notion, I think we'll have quite a number of bugs that pop up that'll be quite interesting of ways to trick like these LLMs to do different things in these contracts. And I've been pitching Goon on this idea of having like almost like a battle bots style subnet where you're like trying to, take money from other people's accounts. And so like everyone gets 1,000 tokens for whatever project they're trying to do. And if you can steal the tokens or make it do things that it's not supposed to do, we'll see who has the most tokens at the end. But not to get carried away by that sort of technical avenue. But really, I think what ends up being really cool is that it can turn anyone that can write any language and turn them into a smart contract developer. And so that notion is extremely powerful, although, will take quite a bit of work to make it effective. But the idea here is that you can actually run the LLM directly on the chain rather than actually compiling into different rule sets or code itself. And the idea is that by skipping all those layers of abstraction and writing very specific prompts, you could potentially, reduce a number of classes of errors, which Goon covers in this conversation and kind of presentation, which I recommend taking a look at. But the idea is that you can kind of string together like a series of changes to some sort of prompt by each transaction, just sending natural language to change the overarching state of what's going on. So, like I said, I think it's a really cool vision for like how blockchains could develop to allow people to do arbitrary actions on them. But I think there's a number of like deep technical challenges before like they actually enter production use and become mainstream. But I think it's something that's really exciting to see how you could potentially use these things to push us closer to the mass adoption of blockchain that a lot of people have been pursuing. So we'll see how it goes. But if you're interested in participating, please reach out to us on GitHub or any other way you want to chat about it. If you're really into LLM stuff, we'd love to work with you on a kind of a basic demo. I think the key here is that the validators themselves should run the LLM directly, and so that would mean that we wanted to use like open source AI models as well. So I think there's a lot of really cool things here. I think one of the big areas of research is LLM determinism. You should be able to get this by seeding it, but there is a lot of float or like kind of interesting multiplication there. So you got to be careful to make sure that works well and stably across all architectures. So there definitely is quite a bit of research to do. So that's one thing. And then selfishly, I'll now talk about the other project that I was working on that I gave a presentation about, which is hyperscalable subnets. So this is recapping what we've learned with the Hyper SDK so far, and then covering where we're going to go in the future. So, I think, and I've probably showed this diagram about 100 times now. So shout out to the Vaults guys for putting this together because I've used it a ton. But as we've seen the growth of subnets on Avalanche, it's been really exciting to see where we're going here as a community and what is empowering and like what sort of activity it's empowering. And so we use the Avalanche network now uses more than 900 billion gas per day, which is more than any other EVM chain, which is really crazy to see and exciting to see in terms of what people are actually using Avalanche for. And this is without warp messaging connected to things. This is without elastic subnets connected. So it's great to see this in early activity. And so as we look at what's coming, Fuji is usually a good indicator. We have this huge map of all these subnets that are currently deployed and running that will migrate hopefully at some point into mainnet subnets as teams work out what they exactly want to do. But the questions always come up is like, well, cool. How many EVMs can you possibly run on the Avalanche network at one time? And I will say we'll probably set a record for how many you could potentially run. But is that like what our goal is? And the answer is no. And so our goal is really to provide, this is my favorite gift, by the way, but to provide a huge ocean of different opportunities of different virtual machines that you could potentially run on Avalanche for whatever your use case may be. And the first real attempt we have put together at like a full alternative runtime has been the Hyper SDK and like the Hyper VM approach. And so I want to give a quick update on that work. And so there's a few core innovations here that I want to re-highlight because we've been spending so much time working on them. The first is this Merkle database that Dan Lane and David Bohm on our side have really been leading. And this is, the joke I always use is a blockchain is really just a thin wrapper around a highly performant database because that's state. If you can't manipulate it quickly and allow other people to access it quickly, you can only go so fast in terms of TPS. And so the first thing we really worked on was building out this path-based Radix tree that allows us to, really efficiently manage the overhead of state while still allowing people to state sync to the network. So, if you're processing 50,000 transactions per second, asking someone to sync from Genesis is going to be quite an ask, and it could take you may never catch up to tip, basically, if you don't have an extremely fast computer. So what you have to do is actually connect to the current state of the network and then just start verifying on a go forward basis. This primitive allows us to do that, which is really, really cool and honestly required for what the use case the Hyper SDK will provide. Secondly, we did a bunch of state prefetching work on top of the MerkleDB to speed up block execution. So this means that transactions now specify the keys that they're going to touch. And then as a result, we can prefetch all the data required to actually execute those things asynchronously. So doing this sort of process allows us to really pipeline block execution instead of saying, go fetch stuff, execute stuff, go fetch stuff, execute stuff. Instead, we can kind of have these two queues that are prefetching and executing as data becomes available. And you can see this in practice. We have a lot of tracing and metrics and everything like that. You can see how like the prefetching bleeds into the execution, which bleeds into the actual persisting to disk. This is something we're still optimizing, which is how long it actually takes to hash the state or get a state root after you apply so many changes. But it's interesting to look at the block as a whole when you look at its like constituent execution steps. The next thing we've talked a lot about is this whole like nonceless transactions. This allows us to basically maintain a much simpler and more performant mempool because we don't actually have to like order all the transactions all the time. This also means that like network gossip can also be a little stupider, I guess, or like you don't need to wait for certain transactions to show up before you can execute them. You can just execute whatever you get right away. And then obviously warp messaging. I think I've showed this. There's an inside joke at the company where like I've showed this slide, probably about 100 times in internal and external presentations. So I'm not going to go over this again, but this slide. And then what that has enabled us to do, at least at a first step, is to create this token VM that has like cross subnet trades, which is really cool. So it uses warp messaging to actually trade for assets across different subnets on import. So you can like buy native tokens, while you're actually entering a region. But the question is, like, cool, all this functionality is cool, but like, the pitch here is performance above all else. So where are we at? Well, prior to Summit, we had achieved about a sustained TPS of around 35,000. And this was, really just through async execution of blocks and then splitting blocks up into smaller pieces so that we could exceed like the 2 megabyte block network limit imposed by AvalancheGO. But we ran into some issues and it was capped out at 35,000. So what was happening was that block verification always waited for build to complete before it could actually verify anything. And so as a result, imagine orange is node 1 and red is node 2. Node 1 is going to start building this block. Let's say that it takes 4 time chunks. We have a network delay for the block to be sent. We'll assume that's just one time. And then let's just say it takes the other node 4 times to also verify the block. Well, during this time, red node is doing nothing. During this time, orange node is doing nothing. And you can't actually start voting on a block in the best case until everyone has gone to 9T. Usually in practice, this may shift from like 9 to 12T based on random network perturbations. And so as a result, you're limited by how many blocks you can actually produce, because the next person can't produce a block until they actually finish verifying the previous block, which slows down throughput. So what we discussed doing was separating blocks into these like smaller pieces that we actually stream during construction, so that you can start verifying part of the block you're still building while the other node is still building it. And so as a result, you can almost like better pipeline build and execution steps so that you can much more quickly get to the point where you're actually voting. And in this case, this would mean that node 2 could actually start to build at 6T instead of 9T. And as a result, the whole network just starts to run faster. So this has been, one of our primary focus, or my primary focus now has been like changing this around to get to this point. And so we actually have a PR up with these changes. It's called millisecond times, which is just the culmination of all my kind of research. And last night we panicked, but we also achieved 50,000 TPS on the same private network with this new architecture, which is pretty cool. Let me share this screen so it can be easier to see. And so the benefit here, obviously, is that more TPS is better for this use case, but also it means that the network is more efficiently processing the actual activity that happens on it. So, as you're trying to, as we think about like what it means to have optimal performance here, it's like as we increase the number of cores on the nodes, can the network activity continue to go up? Or are we bottlenecked by some sort of feature that is not taking advantage of the inherent parallelism of the actual machines? And so this approach has allowed us to much better take advantage of that. And we're still working through a few things related to some mempool things I want to improve. But this approach at least has shown us big gains over what we previously were doing, which was just taking these larger blocks, waiting to get the larger block, verifying. Now we actually stream like the build and verification as a contiguous thing, and it allows us to process more transactions. The other thing is that we're working on what we'll call hyper SDK programs. So this is the last thing, and then we'll turn it over back to the group. But I think smart contracts as a name are extremely confusing to most people, because like I don't write contracts. Like why would contracts on a blockchain imply I should be writing them? And what makes them smart, I guess, is that you can execute them on chain. But really they're just programs. So like what we're going to have on Hyper SDK are just called programs. And programs will let you execute arbitrary code compiled into WebAssembly in Hyper SDK actions. So this will, for the first time, allow you to actually introduce or like have permissionless addition of functionality without actually writing specific actions for it. Now, you'll be able to call different actions that you have written to use those. But for some cases, let's say that you have a like some sort of hyper VM that's hyper optimized, no pun intended, for trading. Well, the trading operation may be natively implemented, but you may want to write different sort of user compiled programs that like stitch together some form, like a number of different trading primitives for some reason. This will allow you to do that without actually having to implement every possible thing ahead of time in code. And maybe if certain contracts get really popular, you could actually, remove the WebAssembly version and then actually implement it natively. But this is what we're really excited about. And I think more importantly, the portability of WASM will let us kind of have this single format that will work on chain also in an RPC, like you could implement the APIs using this as well. If you have like shared access to state, so you could implement arbitrarily complex API handling for your contract, which has been a huge challenge with the EVM, which is like, okay, you know, if I want to parse this contract, I have to like load up all these crazy API, like whatever's parse ETH call, like do all this stuff like that. And it adds this huge cognitive load to actually interacting with the chain. So you'll be able to implement standard RPC access as well. And then lastly, you know, you could actually use some of this functionality to drive activity in the browser. So like, what if you could bundle, you know, the ability to access certain parts of your contract and actually use those parts of your contract on the browser, all in a single kind of format. So yeah, we're definitely playing around with this, and you know, a lot of other teams have spent quite a bit of resources kind of paving the road here. So you know, we think that we'll be able to show some cool POCs sometime in the summer based on this Hyper SDK program idea. So yeah. So that was fun. I didn't think I actually anticipated giving the whole presentation on this, but I think it gives a nice summary of what sort of stuff we have been working on. So I think with that, we'll now turn it over to kind of what's the latest on the AvalancheGO side of things. So I will share my screen and we'll go into that. 1 second. All right, Stephen, go ahead.
Yeah, no. So I think we just kind of want to talk about the last AvalancheGO release, which was 1.10.1, and then I'll probably talk a little bit about the upcoming release, which is 1.10.2 as well. So 1.10.1 was kind of the big cleanup of post 1.10. So 1.10 again performed this kind of X-chain linearization in Cortina. So we migrated everything to live on top of the Snowman and the Snowman++ consensus engine. So we were able to kind of finally migrate everything to that. And so now we just have to maintain that one major consensus engine. So this ended up cleaning up that and removing the DAG engine. And then it also ended up introducing and cleaning up a bunch of APIs for the exchange that various like exchanges and indexers wanted and things like that. So a couple other small bug fixes, but really 1.10.1 and 1.10.2 have been focused primarily on a lot of cleanup and stability post 1.10. So we're trying to we always do this thing where we do this kind of like big push to get the feature out the door. And we always definitely maintain like a high level of confidence in the code base, but definitely afterwards, we like to go through and kind of fully clean things up and make sure that we're like at a good starting point to kind of launch our next kind of project off of. So so that's kind of the current focus with 1.10.1 and 1.10.2. And yeah, I think that's kind of all I really want to say on here.
Yeah, I wanted to call out for those that haven't noticed. So 2 things on the public repo. One is if you go to issues, if there's anything that's bothering you, first of all, like please, you know, post it here because we do pay very close attention to the issues, and we now mark them with this thing called the project board, which we call Ski Patrol. Ski Patrol is a full view of everything that's going on related to AvalancheGO. So, you know, the full backlog, all issues or PRs, things that were selected for development, things that are in progress, things that are in review, and things that are frozen, you know, blocked, and things that are done. So when people ask us like, hey, you know, I've been trying to get involved with, you know, AvalancheGO development, but I have no idea what's going on. We have everything here. So if there's anything that's, you know, that's going on, that's happening on this project board. And Stephen has done a good job of basically putting labels on issues that would be a good first issue for people that are looking to contribute. So if you go to label and just go to good first issue, which I think is probably alphabetical, got to remember how to spell, there we go. You'll see a number of starter issues that would be good to check out. So, but other than that, anything that's an open issue that is in the backlog or selected for development would be great ones to try and tackle. So, and all of our, you can also see like what upcoming issues, like what upcoming releases are coming which date that we expect them to land by, and what's actually even included in those releases, and what is like going to be coming right away. So people that are used to saying like, oh, all of a sudden AvalancheGO releases drop and there's all these changes, we have no idea what's coming. Well, all the changes are here. It's pretty clear what's coming. Just look at these links of like what the upcoming issues are. The joke I've been using is like basically GitHub is our PM for most of this. And so we use this as a means to like track everything. So we don't have any secondary source of truth that we're like mirroring things into. Like, this is it. This is what we use internally. This is what you should use if you're looking to contribute or understand what's coming. And the Hyper SDK actually has the same exact thing, as well as Core ETH and 7 EVM. So Hyper SDK is same sort of stuff, same backlog, same tabs, same issues, everything's the same. So this is standardized across all the platform-focused open source projects that we have. The other one that I also want to call your attention to while we're here is discussions. So AvalancheGO enabled discussions. So this is things that are like, I would say, pre-issue or like pre-PR that you want to chat about. So like, if you have any questions on anything or like want to talk about proposed changes to the code base, this would be a great place to post those things. And, we also pay close attention to this. So if there's anything you want to talk about or changes you think, everyone should consider, this would be a really good place to go with that. So, yeah, cool. And then some people had asked about one quick thing, which is there was in the latest Ethereum hard fork, they added a couple of new opcodes, one of which being push 0. And so some people were asking, what does that mean for Avalanche and everything related to that? So I'll turn it over to Aaron to talk about kind of that point real quick.
Yeah, so this Twitter thread pretty much captures it. But as of Solidity v0820, Solidity now supports the push 0 opcode. All that the push 0 opcode is doing is basically just pushing a constant 0 to the top of the stack. So what this means is that if you are operating on any network, as mentioned here, including the Avalanche chain or subnet EVM, that does not yet support the push 0 opcode, if you're using Solidity v0820, it may try to generate that push 0 opcode, which would be considered invalid by any EVM that's not upgraded yet. So as pretty much always, our plan is to integrate this into our next network upgrade. Obviously, adding a new opcode does require a network upgrade. We can't just do that on the fly in a patch version release. So this will be going out in v1.11.0 of AvalancheGO in order to support it. But in the meantime, if you are launching a new contract on the Avalanche chain or subnet EVM, you should be sure to make that you're using Solidity v0819 or below, so that your code will not generate a contract that includes the push 0 opcode, which is not yet supported on Avalanche. I haven't looked into it too much, but it does say that the push 0 opcode is used extremely, extremely frequently, so including in the initialization code as well. And this means that if you were to try and deploy a contract that were compiled with the wrong version of Solidity, it would be highly likely that would actually fail, and you wouldn't accidentally deploy a contract that would fail at some point in the future because of how frequently it's used. So it should be relatively difficult to run into this problem and not realize it. But obviously, right now, Solidity v0820 can generate an opcode that is not supported on Avalanche. So you should be sure if you're building and deploying any contract on Avalanche that you're targeting a version of Solidity prior to v0820.
And I would say, just to kind of build on that a little bit, that best practices is always to test it out on Fuji before sending it on mainnet. So Fuji and mainnet are completely aligned on all of their opcode instructions and things like that. So if you're going to deploy a smart contract on mainnet, I would highly recommend going to the Fuji faucet and testing it out there first. And you should be
just one thing on that, because we will upgrade Fuji, of course, before we upgrade mainnet. So if you're going to be aware of that as well, because when we do upgrade to v1.11, there will be a delay between Fuji and mainnet. So be sure that you're aware of that schedule as well. But generally, of course, yes.
Regardless,
Fuji first.
Yeah, deploy on Fuji first. Test it out. Make sure it works there.
Yeah. So with most of these things, what's important to us on the C chain and Summit EVM is to try to maintain as close of compatibility as possible with the EVM and Ethereum community, so that people deploying contracts can have the same expectations of what will happen. That being said, we do tend to trail them at times by up to one hard fork in terms of solidity changes, in terms of things to the EVM, for a few reasons. Primarily being that if there's an issue, we would like to wait and make sure it's fully stable before we actually add support for it on the Avalanche side. That being said, it overwhelmingly has been stable. It's just a matter of kind of waiting, making sure all the tooling's updated, and then doing our side as well. And usually that'll land in the following upgrade. So I think we have all of those compatibility changes planned for what will be the next upgrade, which is codename D right now. We haven't set a name for that yet, but we expect that to land sometime over the summer as well. So yeah, so I think that's it on the updates that are being planned. Like Stephen mentioned, we do plan to release a new AvalancheGO very shortly, hopefully today or tomorrow, with a few more small tweaks. There's no major changes there other than a massive speed up to get stake, the platform VM endpoint. I think we've reduced the average call time there from 10 or 12 seconds to 100 milliseconds. So for people using the P-Chain API as well as using it locally, it will be dramatically faster. So
it is still deprecated though.
Yeah, getting us to the deprecation smoothly, I would say, is how I describe that. The last thing we wanted to call out before we got into different questions was the new X-Chain Explorer. So for people that have been using the standard X-Chain Explorer, at least the one we've run for some time, if you could share my screen, Kyle. There we go. Thank you. Yeah, we have a fully functional X-Chain Explorer now on our standard subnets endpoint. So you can now take a look at all activity, and you can go back and look at actually link together different transactions across different chains. We still are missing some C-chain atomic transaction activity that will be added very soon. And then once that's there, we'll finally have what I think is a much better UX, the full primary network index, and then we'll be able to start adding tools like different sort of aggregations and metrics on top of the entire thing, which will make it much easier to view all your activity. Now, how this actually works is it's all powered by Glacier. So the Glacier API that we've been working on, that you can all view, it's publicly accessible. The Glacier API contains uniform indexing capabilities for all subnets as well as the primary network. We built this because we needed it for core, but as a result found that it was useful for a number of other things, including building explorers. And so we've been really I think the term is drinking your own medicine, and continuing to iterate this as needed to power all of these different experiences. So for people that are implementing wallets or implementing their own explorers or implementing things, and you want to access activity relatively quickly and powerfully, this is a great way to do it. If you don't if you see something here, if you see something missing here that you need for something you're building, please reach out to us on Twitter or comment somewhere on the forum or something like that with your proposed changes, and we're happy to evaluate them. We're still early in the process of building this service out, and I would love to get your feedback on it. But I also want to give a shout out here to Abascan, who's been doing a great job also indexing the primary network for some time, and it's great to see them pushing as hard as they do to really capture all activity and across this and subnets as well. So did want to call that out as a group that has been taking it very seriously and doing what I think is a pretty solid job so far. Cool. So I think that we can now bleed into the Q&A. So I will prompt some questions from the community, and we'll go from there. So First one, in the latest release, there was a fix for a data race in TXID access during transaction gossip in the AVM. Could you provide more details on this issue and how it was resolved?
Yeah, so this was a race that was introduced when we added in the, okay, well, stepping back, when we did the X-chain linearization, so previously the X-chain, when it was a DAG, did not actually have a mempool because nodes would directly issue transactions into vertices as part of consensus. Post linearization, there is a mempool that then transactions are batched into blocks and then proposed. So when we introduced the mempool, there was some new like transaction gossip that was introduced, and in adding that transaction gossip, it was possible for the ID of a transaction to be calculated multiple times. And so essentially what could end up happening is you could have a transaction whose ID was calculated once and then passed into a different kind of thread where it would then recalculate it. And then on the original thread, it might re-reference it. So there was basically a write that could happen on the secondary thread that was overwriting the exact same transaction ID over the same blob, which depending on how the compiler implements it, could result in some gnarly behavior where you like read the wrong transaction ID. The transaction ID was only actually used, I believe, for logging, and so we just moved the generation and the access of the ID above so that it was unrelated to the secondary thread. So basically, it accessed the ID before passing the whole transaction object to the underlying thread. So it was really kind of a non-issue. I think at worst it would impact logging, or maybe like a best effort kind of like cache thing that didn't matter. I forget what it was. Either way, it wasn't necessarily an actual issue, but it definitely the Golang will yell at you if you have like race detection enabled, and obviously we don't like. Data races are bad, so yeah, that's what that was. So not really a big concern, but good to clean up.
Cool. Yeah, the next one I'll ask for Aaron. So some people reached out saying that their node was using more disk around the time of the Cortina upgrade, and they thought that it was Cortina related. What was that?
Yeah, so this was actually not related to Cortina. Definitely confusing there when we have released an upgrade at the exact same time as you see some difference in network behavior. But this was actually driven by a change in activity on the network around that time. There's a very popular NFT mint that was happening on Avalanche as well as some other chains that was resulting in a much larger throughput of writes that were going through the chain. So normally, and this would impact you specifically. If you were using a non-archival node or an archival node, you would see a surge as well from all of the writes. But specifically, you would see a larger than expected if you were running a non-archival node that's actually pruning data. The reason for this is that as we're processing blocks on the C chain or any EVM chain on Avalanche as of right now, what we actually do is we will keep the Merkle trees for the last accepted block in memory, and we'll only write things to disk every 4,096 blocks. So every 4,096 blocks, we'll actually commit the entire Merkle tree or any changes, since it's a hash-based Merkle tree, from our in-memory dirty cache to disk to make sure that if we restart at some point, we'll never have to, go back to some really, really old block in order to reprocess all of those blocks and recreate the Merkle tree at some point in the future. And so by keeping them in memory in the meantime, we avoid writing more to disk than necessary, but we don't want to keep an infinitely potentially very, very large amount of dirty Trie cache nodes in memory. And so what we do is we actually have a limited size to this, which was set at 256 megabytes. And that means that if there were, in the course of 4,096 blocks, a large increase of the size of dirty Trie cache nodes that went above 256 megabytes, then you would actually flush those to disk which in normal operation, if that 256 megabytes was enough to avoid writing it into disk, would cause you to write more storage to disk than normal. So in the latest release that's going to be coming out either this week or next week, we're actually going to just be increasing that default cache size. It's a super small and trivial change, but it should result in it being much less likely that you'll have to flush data to disk that would otherwise be unnecessary. And if you are ever experiencing this when you're running a non-archival node and you only really need the active state, you can always run offline pruning in order to delete any MerkleTree nodes that are not part of the active state. Or you can also just resync your node using state sync, and it will only sync the latest active state, so you won't have any old MerkleTree nodes. It'll also not sync old blocks, since those won't be necessary in order to continue processing the blockchain from that point on. So if you want to reduce the size of storage used by your node and you don't need an archival node, then you can very easily either run offline pruning or state sync in order to get that as well.
Cool. And the last one that we have for Stephen, so I think it's another pretty minor one, but want to make sure we get to the ones that are asked. So the uniform sampler now supports sampling numbers between maxint64 and maxuint64. This seems to be a specific enhancement to the random sampling process. Could you elaborate on the technical implications of this change? How does it improve the randomness or fairness of the consensus process, or is it unrelated?
Very good question. So if you ever talk to me about data structures and random sampling, you will know that I can go off on tangents, and I love to talk about this. I swear I did not ask this question, but yeah, good question. I like talking about it. So prior to that change, it was only possible to generate a random number between 0 and maxint64, which is like 2 to the 63 minus 1. And so that was fine when we originally released, because the maximum total supply of Avox is 720 million Avox, but that's actually denominated on chain in nano Avox, which is a billionth. And so if you actually do the math out there, it is beneath the maxint 64. So even if 100% of the total token supply was staked, and you had to select a nano Avox somewhere in that range, it would be totally fine. But with the kind of like rise and more adoption of subnets, we wanted to kind of fully close any edge cases that could happen where you have like extremely large amounts of their subnet token staked. And so this is really just kind of making it so that we have a matching bound for any subnets that might have that kind of level of supply. So there's no impact necessarily on the fairness of the randomness or really of the performance. In fact, the prior implementation and the current implementation, if you're requesting a number that is less than maxint64, then the results are actually identical. And that's actually a requirement for this change because the proposer VM for Snowman++ actually uses this. So this is really just explicitly expanding the case to be able to sample a random number in that higher range with that last bit of information. So yeah, that's really all that's happening there. The whole algorithm is designed so that assuming your underlying random number generator can generate a random number between 0 and maxuint64, then this will generate a perfectly unbiased random number between 0 and n, where n can be any number between 0 and maxuint64. So that was really all that was happening there. Really, it was just to clean up a bunch of error handling that we had along the way. So now, if you can fit inside of that that variable type, then you can request any number. You don't have to do any error handling. So that's really nice. Yeah.
Cool. Yeah, so we're running up on time here. I think we responded to all the questions that we got ahead of time. As a reminder, if you'd like to ask a question, you could submit it right when the post goes live for the next Dev Community Call. and we'll get to that. So yeah, with that, I think we're good to go here. So thanks again for joining the community call, and here's Gabriel to wrap us up.
Awesome. Thank you so much, gentlemen. It was great to hear all that. I want to pass the mic around one last time to get final thoughts, and please share your social where people can find you. First, Stephen.
Final thoughts. Always looking forward to launching kind of the next big thing. So looking forward to getting kind of these cleanup PRs and AvalancheGO out of the way and focusing on the next kind of major feature in 1.11. So yeah, just really excited to keep heads down working on stuff. Always have fun. Always working on some fun stuff here at Ava. So yeah, social. I don't really do much social media, but if you want to follow me on Twitter, you can at Stephen Buttolph. Yeah, that's about it.
Awesome. Thank you so much. Aaron?
Yeah, final thoughts. I guess just great to meet everybody that was able to come out of the Avalanche Summit #2. Great to see you guys and see what everyone in the community is building. For me, Twitter profile is just Aaron Buchwald. See everybody.
Thank you, sir. Patrick?
Yeah, just working more on faster HyperSDK. So trying to take the best things that come out of that and bring that to the rest of the platform as we learn things. We've already, optimized a ton of different things inside of AvalancheGO as a result of, our learnings there, especially with the MerkleDB. So, regardless of whether or not the HyperSDK you plan to use it, it will make the world of Avalanche better for you, hopefully. So you can follow me at @_Patrick O'Grady on Twitter.
Wonderful. Thank you again, gentlemen. My name is Gabriel Cardona. As I mentioned, I am a developer evangelist at Ava Labs. You can follow me on Twitter at CGCardona. That's CGCardona. Also, I want to announce that we have a new developers handle on Twitter. It is Avax Developers. That's AvaxDevElopers. Please go follow that so you can keep up to date on all of the cool stuff that's coming out of the engineering department and around the entire ecosystem from Ava Labs. We want to, encourage everybody. We're going to be doing this every 2 weeks or so. So please check back in on 2 weeks and we will have more exciting announcements. But that's it. Thanks again, gentlemen. And thank you to all the amazing developers out there. Thanks to everybody who came to the summit. It was great to connect with everyone. And we will see you next time. Thank you.